then the change is subtle and people don't notice it. Is that
Exactly.
what the message there is?
Yeah, it's subtle. It's so far it's gradual. I mean, there could be tipping points or abrupt climate change, but so far it's a relatively gradual change against a backdrop of huge variability from year to year, season to season. The way scientists describe it is the signal versus the noise. So if the signal is climate change, it's hard to see against a background of a huge amount of noise, which is the natural variability. Yeah.
Do you think we're,
Yeah.
I do want to, just to build on that question Toban had about like getting through to people and how do you convey a message of adaptation. So I think the climate change debate, is it real, is it not, is that maybe it's not even, doesn't even matter. What we need to talk about is what's happening on your farm, what's affecting your ability to produce a crop, and how do we improve the practice to adapt to a longer season, warmer summer nights, maybe milder winters that may affect insects or pathogens. I don't know. So how do you take the skepticism and convert it into some helpful action on the farm?
You're exactly right. It's hardly even necessary to talk about global warming. In fact, I try to avoid using that terminology. And there are people, most producers are curious people, and their industry is science-based, so they read the science and online when they have time. And so they'll ask me questions about global warming and the causes and so on. And I'm always reluctant to go there because we're really here to talk about not the causes of a rise in temperature of the whole world, but how is your operation, how is your community affected by weather and climate, and how do we see that changing into the near future, and what are you going to do about it? So that's the crux of the discussion. And I also appreciate the fact that producers are very aware of the fluctuation in soil moisture from season to season and year to year.
Mm-hmm.
And it's so large that it's difficult to see that gradual, we call it incremental change, as resulting from a warmer climate. And so to me, it makes perfect sense. I have colleagues in the social sciences and social psychology and psychology who try to explain the attitude of producers in terms of who they are, how they behave, and what they think. But I think there's a much simpler explanation. They're just exposed to a whole lot of variability that obscures the gradual changes. And when you say, well, how do you get through to them? I usually start with the tree rings.
Yes.
Yeah, that's a great segue.
All right. What do you do with the tree
because,
rings?
And for various reasons. I mean, one reason is most of the trees are on farmland, ranch land, actually. So we have to work with producers to access the trees. And they're incredibly cooperative. Like they say, the cattle don't eat the trees, they eat the grass. So as long as you don't set the grass on fire, you can take those trees down. Well, not take them down, but sample them. So we have a lot of interaction with producers just in the course of our field work to gain access to old trees. But also, they understand that trees are a plant and need moisture, and they understand that the tree ring story, the reconstruction of climate from tree rings, is real. It's a climate that actually occurred. And it's very, models, it's just make-believe, it's just made up. I mean, it's all we have for a future climate, but after all, the climate that the models produce is just hypothetical.
Sure. Yeah. Easy to dismiss anyway. Yeah.
When I think of a tree ring, Dave, I think of, a dark line. I don't know whether that's winter, and then a lighter colored space that varies. And then you get another black line or dark line. So what?
Walk us through that. Walk us through it. Oh,
Here
here we
go.
go. Nice. We get the visual.
So I want to know what is a tree ring and what does it tell us? Oh, here we go.
Nice.
My office is full of old wood. It smells good. And down the hall, we have thousands and thousands of pieces of old wood. It's the annual growth, and we have an ideal climate because we have a very sharp and short growing season. So there's a definite end to the growing season, to the growth of the trees. You can't do this kind of work in the tropics because the trees never stop growing, right? Although they try. But it works well here. And so if you look at a tree ring, it's actually got two parts. There's a light-colored part and a dark-colored part. The light color is the early growth. In the spring, where usually there's decent soil moisture. And then as the summer and growing season proceeds, the soil tends to dry out, but also it's cooling off. And so the tree growth slows and it produces a darker, denser ring. So we actually take 2 measurements per year of the early wood and the amount of late wood, and we take very precise measurements. So we have almost 4.8 million measurements of tree growth. And in a dry climate, it's a proxy for soil moisture because that's what limits tree growth. So, I mean, if you took wood from a cold place, so you get a temperature record. But in our part of the world, really, nearly everywhere, soil moisture is what limits growth. Yeah.
Okay. So the width of the ring.
What kind of messages are you getting?
How much more? Yeah. So we're learning how much moisture happened in a year based on how wide the light colored ring is. What else does it tell us? Does it tell us anything else useful? You said temperature in the north, but
it depends where you collect the wood. I mean, we've collected wood high up in the Rocky Mountains, and when you get to a certain elevation and the trees disappear because there's not enough heat. So those tree rings tell us how much heat was available each year. And that's why scientists who do this kind of work are able to determine that there's been a lot more heat in the world in the last few decades than prior millennia. It's some of the most convincing evidence that, yes, our climate is warming at an unusual rate. It's from tree rings collected at cold places. But we do most of our collecting up and down the foothills and the eastern slopes of the Rockies, across the southern part of the boreal forest, down into southwestern Manitoba, southeastern Saskatchewan, where there's oak trees, old oak trees. And we cross the border because the climate doesn't change at the international border. So we collect tree rings in Montana and North Dakota. And where it's dry, and so we know that what's driving tree growth is how much water was available each year.
What is it? Why oaks?
Oak because they get old, 3 to 400 years, some of the oak trees. And they also are quite sensitive to the availability of water, more so than other trees.
Did you ever test that old oak tree in Surrey that just fell down? It was 600 years old or something like that?
No, we should.
It's gone.
I know.
Now.
We have to check it out. Yeah.
Too bad. Well, if anyone tells us about old oak trees, mind you probably know where all the old oak trees are on the prairies.
No, not necessarily.
No. What's the oldest tree on the prairies?
Or oldest one.
The oldest tree in the prairie provinces would be in Alberta for sure.
In the mountains or out on the plains?
No, in the mountains. You get trees that are well over 1,000 years old. Yeah.
Oh, wow.
Oh, wow. That's
because in the mountains there's natural fire breaks, right?
Yeah.
And you won't find old trees elsewhere because there's nothing to stop the fire and kill the trees. But we keep looking. We keep looking for places where the fire hasn't been recently, and we find trees that are centuries old. But the really old ones, the ones that are exceeding 1,000 years, would be out west from here.
So have the trees ever told you something data-wise that other data wasn't able to show?
Yeah, and that's the big advantage the trees have is they're annual. The rings are annual, right? So we have annual, we have subannual, we have seasonal data from the tree rings. There are a lot of scientists who do what's called paleoclimate research. We look at the climate of the past and they collect ice cores from ice sheets and glaciers. And a lot of the work is based on lake sediments because everything in a watershed eventually gets washed it to the lowest elevation into a lake or a wetland. So a lot of these scientists have produced incredible reconstructions of the climate, including the prairies, based on cores taken from lakes. Only problem is you can't necessarily know the age of a layer of mud to within a year or to within a season. There's a few exceptions where in deep lakes the sediments laid down in layers, but on the prairies we have fairly shallow lakes, and the wind comes along and stirs up the mud, and so it's like the record is being averaged every time the sediments get stirred up and settle back down. You've destroyed the chronology, and so there's really good information of the climate of the last 10,000 years since the glacier left, but it tends to be relatively coarse compared to the tree rings, which are subannual. So that's a big advantage we have.